Good day. So, this will be now yung continuation ng ating ideal Rankine cycle. So, anong gagawin natin dito, sir, ngayon? We will solve a problem. Ah, Single problem lang to. Siguro good for a couple of minutes. Na-familiarize naman na tayo dun sa ating steam tables, dun sa processes that is involved in your Rankine cycle. Mas maigpit ako pagdating ng plotting eh. Kasi dyan yung makikita yung quality ng steam mo. Kung if that is saturated, if that is wet at different points, at several points pala, or at a specific point, kung siya ba is superheated, if it is a compressed liquid, a saturated vapor, or simply just it is a wet mixture. Now, this is the problem. Sample problem number 1 for your steam power plant. Okay, the problem goes like this. A turbine receives steam at 10 MPa at 600 degrees Celsius. So we might say this is the one that is supplied by the boiler, okay, to your turbine. So dito manggagaling yan. So this is P1 and T1. And exhaust it, pwede rin extracted ang word exhaust or extracted. It at 0.2 MPa. So that is, now kapag in-exhaust mo, ibig sabihin it went to the condenser. Or simply out of turbine. Draw a schematic diagram and plot the condition of the steam in TS diagram. Also determine the following. The enthalpies at all points, so that is 4. I think those are the 4 enthalpies na kailangan mo. The QA and QR in kilocalories per kilogram. So, alam natin dapat yung conversion unit ng kilocalories. Kilojoule to kilocal. Okay? And then, well played po. Hindi. Work ng pump and then work ng turbine in BTU per pound mass. The net cycle work in feet pound per pound mass and then the thermal efficiency of the Rankine cycle. Wag muna tong engine, ipapasok ko na lang yan next meeting. Okay? Or pwede rin dito, pwede natin isa-isama. Madi-derive naman natin yan. Now, let us go with the determination of all the points. Okay? So, set aside muna natin tong PV diagram. Okay? Ang sabi sa problem, that the turbine receives the steam at 10 MPa at 600 degrees Celsius. So, the turbine. Tanggalin natin itong mga notation na to, ha? Mali yan. Sundin natin yung ating numbering na tama. So, from here, this is 1, this is 2, this is 3, this is 4. Now, kung titignan natin, inisinupply daw dito at P1, 10 MPa, and then T1 is 600 degree Celsius. You can look at your steam tables at saturation pressures, okay? Tingnan yung saturation pressure dyan. Saturation pressure na 10 MPa. Saan yan? Table 2 in your steam tables. Now, what is the saturation temperature at that saturation pressure? So, we can say, as you can see naman, nandito sa dulo ng table 2, the saturation temperature of 10 MPa is at 311.06 degrees Celsius. So, which means, the actual temperature given is greater than T1 is greater than your Tsat. We can say it is superheated. Okay? Superheated yan lumabas ng boiler. Now, when it is extracted, may sinabi ba dyan, class? May sinabi ba na it is exhausted at 0.2 MPa? So, what will we do? Okay, hindi natin alam if that is a wet steam condition or simply a liquid condition. Okay. In-extract mo daw dito at P2 is equal to P3. 0.2 MPa. We will see pag sinolve natin. Okay, at all points, we will have to solve all the enthalpies. A. Solving for enthalpy. Enthalpies. Okay. So, at P1 and T1, at P1 is equal to 10 MPa and E is equal to 600 degree Celsius. Ano yung mga kailangan natin dito, sir? Kailangan natin si H, H1. Kailangan natin si S1, which is, will be equal to S2. Yan. So, alamin na natin yan, okay? Tingnan mo dyan. At P1 and T1, nasa 10. Oh, so, go to your table 3, vapor. Tingnan nyo kung meron siya sa kalagitnaan. Kung meron 10 dyan, ha? Meron kayo makikita dyan? So, 10, 600. 10, 600, meron kang values na 38.37, 32.41 for you, 36.25.3. 36.25.3, that is H1. 36.20, 36.25.3. Kilojoule per kilogram. Now, yung S2 at saka S1, equal yung dalawa. So, tinitignan ko siya dito sa aking steam table. 6.9029. Tama ba yung nakuha natin? Check natin mamaya. 6.9029. Anong kanyang value? Kilojoule per kilogram degree Kelvin. Now, let us check. Okay? So, hanapin natin yung dalawa. Huwag nyo lang hanapin yung V1 tsaka yung U. Hindi naman kailangan yun. Now, at point 2. Okay? At point 1. At point 2. To the turbine. Turbine out. Ang binigay lang dito is the pressure. So, pressure 2 is equal to pressure 1. Pressure 3. And S1 is equal to S2. Where S2 is simply, hanapin natin to sa saturation ba? Hanapin natin siya. Saan mahanap yan? SF2. Okay, and then SFG. Hanapin mo sa table 2. Go to your table 2. Table 2 ba? At 0.2. At table 2. Puntahan niyo yung pressures. Saturation pressure, 0.2. Mag-interpolate po ba tayo dyan? Yun, may sakto. So, the T-sat dito at 0.2 MPa is 120.23. So, what do we need? Yung SF, HF, tsaka HFG. What we have to find is SF2. Yan. Tapos yung SFG2. Tapos yung HF2. Tapos yung HFG2. Yan. Hanapin natin yan. From here, we can get equality. Okay? We get the quality of the steam. Okay? Get the quality of the steam. X is S2 minus SF over SFG. 2. So, S2 is 6 point. Pakitignan na lang. 0.2 15301 tsaka 5.5970 yung SFG. Correct? So, 6 point. Ito ang process At point 2, di ba, is S1 is equal to S2. Meron siyang binigay na pressure which is 0.2 MPa. You look it up at table 2. look it up at table 2. Ayan, lagay mo dito. At table 2. Ayan, table 2 mo kukunin yan. So, SF2, hanapin ko dito. SF, 1.5301. 1.5301. Tapos, yung isa, 5.5970. 5.5970. Both units are kilojoule per kilogram degree Kelvin. Now, for HF tsaka HFG, kunin mo na agad. The HF is 504.7. 504.7 kilojoule per kilogram. At yung HFG, 2201.9. 2201.9. 2201.9 kilojoule per kilogram. Now you have to check for X or the quality of the steam para ma-plot mo siya ng tama. Okay? So for the quality of the steam, S2 is 6.9029 if I'm not mistaken minus SF2 1.5301 over SFG 5.5970 equal to yun natin. On. Yan. So 6. Check natin. 9029. 9029 minus 1.5301 over 5.5970. 5970. Yun. So 0.9599. Pag quality, tandaan nyo, pag quality parate, lagawin yung 5 decimal places. 0.95994. You store the value at A. Yan, magko-close ulit siya. Okay. Huwag natin store. Baka magkamali-mali pa tayo. So, you can now get for the value of H2. For the value of H2, di ba tinuro ko sa inyo, that H2 will be equal to HF2 plus X and HFD. Oh, yan, masolve natin. HF2, saan mo nakuha? Ayun, 504.7. 504.7 plus yung X, 0.95994 multiplied to HHG, 2201.9. 2201.9. Anong unit nito? Kilojoule per kilogram. So, 504.7 plus 0.95994 times 2201.9. The answer will be 2618.3919. So, 2618.3919. Anong unit? Kilojoule per kilogram. We box the final answers. Yan. H1, H2. H3 naman, di ba? Ang sabi ko H3. Ang H3, papasok yan sa pump theoretically. So, H3 will be the enthalpy at pressure 2. Kaya lang, compressed liquid na siya. Saturated liquid. So, at point 3, yan, where P is equal to 0.2 kasi P1, P2 equal to P3. MPa. Yan. Ngayon, yung HF2 mo is equal to H3. And that is 504.7 kilojoule per kilogram degree Kelvin. Now, go back to 0.2 MPa at table 3. At 0.2 MPa, table 3, at table 3, table 2, saturation pressures, you will get yung value ni VF. Okay? The value of VF is Divide mo ng 1,000. So, 0.0010605. Ilan to? Cubic meter per kilogram. And that is VF. Now, what have I taught you nung nakaraan, pagdating ng ating Rankine, that if you draw this one, yung pump mo, okay, tandaan mo yung pump mo, isusupply niyan is H4, isusupply dito sa pump mo is H3. At what pressure? Siyempre, pressure 3. Anong pressure nandito? Pressure 4. Diba? Tapos mag-i-input ka ng work ng pump. Now, for the work ng pump, makikita mo dyan that pag nag-energy in, energy out ka, okay, gamitin mo to, energy in, energy out. Lahat ng in equal sa out. So, you can solve for H4. H4 will be equal to work ng pump plus H3. But the problem is, you don't have work ng pump. So, makuha yung work ng pump. Di ba, binigyan ko na kayo ng shortcut. Sir, yes sir. Tignan nyo to. Work ng pump is equal to yung VF at pressure 3 or the pressure at the condenser multiplied to the pressure na hahabulin niya, which is 4, and then the pressure that it will be supplied to the pump. Siyempre, yung condensing pressure, P3. Now, paano natin masosolve? Lahat to naka-MPa. Tandaan nyo, naka-MPa ito. MPa to MPa. Ano ba ang value dapat ng work ng pump? Dapat to nakalagay is kilojoule per kilogram. Okay? MPa. Ano bang unit ng MPa? Eh di 1,000 tapos kilonewton per meter squared. Tapos multiply mo sa BF, multiply mo ng meter cube per kilogram. Di ba ang kilojoule is kilonewton meter? O di ma-cancel to, may matitirang isang meter. O di kilonewton per kilogram or kilojoule per kilogram. So you have to multiply itong buo ng 1,000. 1,000 multiply to VF, which is 0.0010605 meter cube per kilogram. Tapos, yung pressure na habulin niya, ano ba yon? Nakalagay dyan is 10 MPa. Ayun, 10 MPa. So, this is 10 minus 0.2 multiplied to, wala na pala, na yun pala yung 1,000. Kilo Newton per meter squared. Yun. So, we can solve for the work ng pump. 1,000 multiply to 0.001060605 multiplied to 10 minus 0.2. Okay. So, that is 10.3929. Napakalit ng work ng pump, no? 10.3929 kilojoule per kilogram. Now, you have the work for the pump. We can solve for H4. H4 now will become 10.3929 plus yung H3, which is 504. Ayun, no? H3. 504.7. 504.7. 504.7. Anong unit? Kilojoule per kilogram. So, yan na lang natin to. Plus 504.7. The answer will be 515. 515.0929 kilojoule per kilogram degree. Kilogram degree Kelvin. Kilogram lang. So, we can now solve for the parameters na hinahanap sa kanya. Ano yun? Solve na tayo kay letter A. Okay? Letter A. Solve na tayo dyan. Letter, ano na lang tayo? Letter B. QA and QR. Okay na si A. Si B na lang. QA and QR. Drawing natin para hindi tayo mahirapan, okay? B. QA and QR at kcal per kilogram. Now, ah ah sa kilocalories, ano yung kanyang conversion factor? Yeah. What is the conversion factor for kilocal? Tandaan nyo, ang conversion factor, ito yan 1 kilocalorie is equal to 4.187 kilojoules. Yan. Tandaan nyo ito. Yung ating conversion factor. Now, what better way to solve it is to know yung kanyang, yung kanyang boiler, idodrawing mo. Okay? Tapos, imamapping mo ngayon. So, meron kang H1. Tapos, yung supply dito. Okay? Yung sinupply mo dito is H4. Tapos, yung supply dito, which is QA. Again, babanggitin ko sa inyo, kung meron kayong combustion, QA is the amount of energy na yung fuel nyo is i-input dun sa inyong boiler. And since wala naman combustion yung iba sa inyo, hindi natin papasukan ng combustion. Pero kung meron nga kayong combustion, magkakaroon tayo ng energy calculation pagdating ng fuel. Now, E-in and E-out. Okay? Lagi kayong magko-convert sa final answer. Lahat ng pumasok, equal to lumabas. Okay? Pero ang hinahanap natin kasi is QA. Yan. Ang hinahanap natin is QA. So, QA will be equal to, wala naman tayong mass, di ba? So, specific lang yung work dyan. So, H1 minus H4. So, QA will be equal to H1. Recall natin yung H1. H1 is H1. Saan yung H1? 3625.3. 3625.3 minus H4. What is H4? 515.029. 515.029 kilojoule per kilogram. Kaya lang kilocal tayo. So, multiply mo dito. 1 kcal per 4.187 kilojoule. So, final ka na parati mag-convert. So, this is, okay, dito. 3625.3 minus 515.029 divided by 4.187. Yan, 742 QA. 742.8 4.8 4 na lang, 84 kilocalorie kcal per kilogram. QR naman. Drawing mo, saan po ba nangyayari yung QR? O di sa condenser mo. Okay. Yan, condenser. Yan. Meron ka supply dito ng H2. Lalabas yan as H3. Tapos dito yung labas ng init, QR. So, by energy balancing, E-in is equal to E-out. Simply, QR will be equal to H2 minus H3. Okay? So, QR. Ano ba H2? H2 is, H2. 2618. 2618.3919. 2618.3919 minus HF2 or H3. 504.7. 504.7 kilojoule per kilogram multiplied to 1 kilocalorie per 4.187 kilojoule. Yun. Solve. Balik ka na lang dito para hindi mo na ulit-ulitin. 2618.3919 minus 504.7. Now the answer is 504.823. 504.823 kilocalorie acal per kilogram. That is the answer for QR. So, solve na natin si B. Okay? Medyo na isa-isa na natin. Sa work ng pump, BTU per pound, yun din, yung work ng turbine. Now, for the work ng turbine, okay? Na-solve naman na natin si work ng pump. C. Work ng pump and work ng turbine at BTU per pound mass. Yun. Turuan ko kayo dyan. Excuse me. So, work ng pump, nakalagay dyan is, na-solve natin yun 10.3929. 10.3929 kilojoule per kilogram. Ang hinahanap natin is BTU per pound. Anong niyan? Anong kanyang conversion? 'Di ba? Note natin. Note. Oh, hindi na alam yung conversion factor, patay tayo diyan. 'Di ba ang 1 BTU is equal to 1.055 kilojoule? Nako, hindi na alala. Oh. Ilang ilang pound per kilogram. So, 1 kilogram, ilan? 2.205 pound mass. Oh, nako, hindi na alala ng mga tropa natin dyan. Patay tayo dyan. Yari na pag hindi nyo naalala yan. So, 10.3929. Nga. 10.3929 multiply mo ng kilojoule per kilogram. Conversion factor niya. 1 BTU per 1.055 kilojoule. Tapos, multiply mo ulit. Yung kilogram. So, 1 kilogram, 2.205 pound mass. Oh, nako, hindi na alala ha. Alalahanin yan. Oh, cancel yung pare-parehas. Ano tira? Yung kailangan natin. Oh. Alalahanin niya, malapit na kayong graduate. Madalas, English units ang board exam. Hindi nyo dapat makalimutan yan. Times 2.205 for the answer na ilan ang naging answer dyan? Kilojoule. So, in, out. Okay. Maliit lang talaga ang pump. 4.4676 BTU per pound mass. Yun, meron na tayong work ng pump. And then for the work of the turbine, you have to draw the turbine para maintindihan nyo. Ay, ito yung turbine, parang turotot. Ayan. Now, nag-supply ka dito as H1. lalabas yan dito as turbine work. Okay? And then lalabas dito as extracted steam, which is H2. Now, energy in is equal to energy out. Now, lahat ng out, so WT, work of the turbine, is H1 minus H2. So, the work of the turbine, what is H1? 3625.3. 3625.3 minus H2. Ano yung nakuha natin? Dito na yung nasolve natin yan. H2, 2618.3919. 2618.3919. 2618.3919. Kilojoule per kilogram. Multiply natin ng conversion factor. So, 1 BTU, 1.055 kilojoule. Tapos, yung kilogram. 1 kilogram per 2.205 pounds. Okay, meron pang isa na conversion. Babanggitin ko na lang. 1 English ton equal to 907. 1 English ton is 2,000 pounds. O that is equal to 907 kilograms. Okay? Tandaan nyo yan. Pag sinabing 1 ton, that is 1 English ton. T-O-N. Calculate natin ito. 3625.3 minus 2618.3919 over 2.205 times 1.055. The answer will be 432.8414. Work of the turbine will be 432.8414 BTU per pound. British thermal units per pound mass. That is for the work ng turbine. Solve na natin siya. For letter C. Okay? Diba? Medyo mahaba lang talaga. Net cycle work. Work net. O di minus na lang natin itong dalawa. Ano bang unit? Pound feet per pound mass. Work net. Since ang hinahanap nyo is imperial units, D. Work net in pound feet per pound mass. Pound force to eh. Okay, magmula na lang tayo dito sa mga work na binigay dyan. Work net, wag na sa QA at QR. So, work ng turbine minus work ng pump. Somehow, pag napakaliit naman ng value nun sa pump, all you have to do is to eliminate na lang or neglect mo na lang yung work ng pump. Ganun yung mabilisan. Ngayon, sa board exam, mostly, ang nangyayari dyan is parang ninineglect nila yung work ng pump. Pero pagdating sa atin, since this is ideal calculations and then academic calculations, kailangan idinadagdag mo pa rin yung sa pump. Pero pagdating ng board exam, for estimation, okay, hindi naman kailangan doon masyadong sakto yung value mo. Pwede mo i-neglect yung power ng pump. Okay? So, 432.8414 minus the work of a pump. I think that is 4.4676. 4676. Ano yan? BTU per pound. Ngayon, ang hahanapin natin dito, ilang BTU per foot pound? Ngayon 1 BTU is equal to 778 feet pound. Nako, nalimutan na naman natin yung yung kanyang conversion unit. Paano yan pag nalimutan mo? Di patay na tayo dyan, Di na. Dapat kabisado nyo yan, ayan, 1 BTU equal to 778 feet pound. Alalahanin to mga kaibigan. Yari tayo dyan pagdating ng board exam. So, 432 minus ko na lang to ng 4.4676. Okay. And then, i-multiply ko na ng 778. Lalaki ang value. 333,274. 333,274.81 feet pound o pound feet per pound. Ano yan? Feet pound na yan. Di ba yan is a measure of torque? Di ba? Foot pounds. Foot pounds of torque, sinasabi nila. For thermal efficiency, sa letter E. Nu T. Okay? Thermal efficiency. O di ganito na lang. E equal to work net over QA. Ano ba mas madali? Work net over QA. Pero ko, ganito na lang. Pwede to. 1 minus QR over QA. Multiply natin ng 100%. Ayan. So, E will be 100%. 1 minus. Ano yung QA natin? Ayan, QA minus QR. So, 1 minus QA. O, QR muna. QR is 504.823. 823. Tapos QA is 742.84. 742.84. Yun. Multiply natin ng 100%. Ang lalabas is tama yan. Pag below 40 or almost 40 pero hindi bababa ng 20%, that is Rankine cycle. Mostly correct ang answer mo pag ganyang range. So that is 32.0415%. That is the efficiency. Normal efficiency ng Rankine cycle. Now, ang tinatanong dyan, for the Rankine engine. Sir, for the Rankine engine, that is, syempre, engine nga the work over EC. Ano ba yung EC? H1 minus H3. Work ng turbine, H1 minus H3. What is the work of the turbine? Ang work ng turbine is, ito, 3625.3. Yan. Ito yung formula for the engine. For Rankine engine. O, di equal din to sa H1 minus H2 kasi yun yung turbine Tapos H1 minus HF. Or, simply, itong F is H3. O, H1. 3625 point 3625.3 minus 2618.3919 3919 over H1 3625.3. Natatandaan ko pa yung HF or H3 that is equal to 504.7. As multiply natin ng 100%. Non-unit na to kasi pare-pareho lang naman sila ng unit. Okay, for Rankine engine, efficiency of the engine, 3625.3 minus 2618.3919 divided by 3625.3 minus 504.7. The answer is 0.32 times ng 100, 32.2665%. And that is how you solve for the entire Rankine cycle. Now for the plotting. Plot na natin yung tama. So, ang mga nakuha nating H dyan, okay, masabi natin, may quality. Yes, your quality is at, bigyan natin yung quality mo. Your quality is at 95%. So, that is in wet region. Sa wet. That is 0.2 Okay. Plot natin dito sa inyong TS diagram. Yung tama. Ganito po ang pag-plot niyan, sir, ha? Turuan ko kayo. So, from here, andito yung inyong 10 MPa, kumari andito, 10 MPa. Temperature natin is 600 degrees Celsius. Okay? So, constant temperature. Andito yung kanyang constant pressure line. Yan. Tapos superheated siya pagdating dito sa dulo-dulo. Superheat siya. Yan. Yan. Curvature. Curving yung line. Yan. Andito. Ayan na yung line mo, ha. Papasok ka dito. Pababa. Straight line kasi constant entropy. Andito yung point mo. Tama nga naman. Under here, wet region yan eh. Okay? Tapos, papunta rito, pabalik. Papatong dito yung sa pump mo. This is liquid. Okay? HF yan. Dito meron kang X. Okay? Tapos sa akit yung bahagya for the pumping. Okay. Yan. Andito yung iyong H4. Yung 4, dito yung 3, dito yung 2, dito yung 1. Where? Ito, constant pressure line. Ito, P1 and T1. Dito, S1 is equal to S2. This is condenser. Okay. That is the TS diagram. And that is for the entire Rankine cycle. Madali pa yan sa ngayon. Okay? So, that will be all for this day. I think meron naman tayo natutunang bago, lalo na sa conversion, tapos yung proper way of solving it. Okay? I hope ma-apply nyo sa inyong mga previous engagements, yung mga binibigay ko sa inyong problems, at ma-apply nyo siya pagdating ng inyong incoming quizzes. Okay? Have a nice day. Bye-bye.